Good afternoon, everyone, and good morning to Steve in the UK. Welcome to the CIC webinar on Design for Safety. I'm Tony Lam, the Industry Development Construction Safety Department. I'm your facilitator today. The CIC has recently formed a task force on the Design for Safety, and we'll start this discussion on how to facilitate the adoption of Design for Safety in Hong Kong construction industry. One of the steps is to conduct a series of seminars to share the knowledge and good practice with the industry. This is the first CIC Design for Safety seminar, and there will be more coming in the near future. Design for Safety is not a new thing to the construction industry, and I bet everyone should have heard about it before and would like to know more about the implementation. Today, we are lucky enough to have Steve Corbin, the Technical Director from Arcadis UK, to share with us on how Design for Safety is applied in UK. Before I pass to Steve, I would like to do some housekeeping announcement. Today, webinar will last for 1 hour, and the presentation will last for 25 minutes, and we will have a Q&A session for 15 minutes. You are able to submit your question anytime you want through the webinar interface, and we will pick up 2 to 3 questions and leave it to Steve to answer. So please do leave your question there. And for those who need to get the e-certificate, the CIC will send you a separate email after the seminar, and you will be required to complete an evaluation form and answer a few questions regarding the presentation contents. So without further ado, let me introduce Steve to give him the presentation. Okay. Good morning, Steve.
Good morning, Tony. Good morning, everyone. Good afternoon, as Tony's mentioned, in Hong Kong. It's cold over in UK, but it's very warm, I believe, where you are in Hong Kong, outside.
Yeah. Yeah, summertime is coming. So you can start your presentation.
Yeah. Okay. Does everyone see the presentation?
Yes. So you can start to control the PowerPoint now.
Okay. Welcome. As I say, it's how Design for Safety is applied. As you can see, various things we're going to go through regarding guidance. I'm clicking on. There's nothing happening my end. Can you see that? Next slide. Yep. Okay, what we have is the Health and Safety Act in UK since 1974. It came into law 1974, but it actually was applied in 75. Then we had the management regulations, which all set the tone of risk assessment required by all employers. And then we had the construction design management regulations to address construction. This started about in 1994 with the first set of regulations. They've been amended now 3 times, and which we have the CDM regulations 2015, which we will be going through now, which you can see on the left-hand side, which comprises of 30 pages, which is supported by guidance. What we used to have was a approved code of practice, which was 124 pages in the previous regulations, the CDM 2007. Now under CDM 15, we have 90 pages with very few flowcharts. So what the industry has done to support and help duty holders is develop various booklets such as that called the Principal Designer's Handbook, and we also have a CITB set of guidance for each individual duty holder, from client, principal designer, principal contractor and contractor, but also for the workers. And in conjunction with that, we have various other legislation, working at height regulations, electricity at work, confined spaces, control of substances hazardous to health, asbestos, hand-arm vibration, noise, but also lifting operations, lifting equipment regulations, which designers still have to look at in conjunction with the contractors to try and eliminate and reduce the risks at source as soon as possible, which we were going through. We just mentioned about the CIT publications. As you can see, principal designers. We also have various professional institutes that no doubt you are members of anyway. The Institute of Chartered Engineers. We have the what we call the ICE Design Risk Management Guidance, which is continually getting updated for members, which I input into in conjunction with REBA for the for architects, built-in architects, and their CDM guidance, which we will come on to, where there's some modifications going forward and clearer guidance about what to address early in the design for buildings per se. And also we have the Syria guidance, which you can see, one for construction work, what we helping designers to focus on what about buildability. The middle one there is about the workplace. It's in use of the actual asset, the building, during its operation, and what should be designed out, incorporated. And on the right-hand side, which hasn't been amended since 2009, is the safe access for maintenance and repair of that building asset. Very good guidance. So what does this mean to designers? Well, we had mentioned about the legislation. The regulations place specific duties with respect to health and safety, and our continuation of current philosophy to emphasize the right information to the right people at the right time. That's absolutely paramount. And that can only be done by collaboration, and we've constantly heard continually, but that can only happen with all the C words. And that it starts with communication, cooperation, consultation, competence of the individuals, and control. All those need to work hand in hand in order to get collaboration in its essence together, without withstanding commitment from all parties. It's also not just a top down, it's a bottom up as well required. It's a team effort. Everyone has to play their part and understand their responsibilities for the whole of that project, not just for the construction work, but the whole life cycle of that asset once it's been completed and during its maintenance and operation. We come on to the procurement, which is the Achilles heel. It's about having the right application, set the parameters at the start by the designers with the client, getting clear understanding who's doing what, when and how is crucial and needs to be built into the contracts. Some of the contracts do conflict. That's why it's necessary to have that dialogue early on to ensure the legislation matches what's in the contract, vice versa. Regarding appointments and setting minimum standards are crucial. So we come on to competence we mentioned earlier. The client, the developer, where it is reasonably foreseeable more than one contractor in UK working on a project. Anytime the client developer must appoint in writing a designer with control over the pre-construction phase as this role of principal designer, which is known in Singapore as design for safety professional, as you may have heard. And a contractor as the principal contractor for the actual construction works. And that could include the enabling works prior to the main build and also demolition works. A designer, including the principal designer, or the contractor, including the principal contractor, need to have the necessary skills and knowledge and experience. And the duty to ensure that is both parties, the client and those respective parties. Need to have the organisation capability to understand their responsibilities and secures the health and safety of any person affected by that project. So regarding setting the competence here, which you can see in the first essence here, we have the first line, competence, for a single project, a multidiscipline project, and a large complex. we have various categories that's been set up by various companies, part of a consultation group with the health and safety executive. This is purely for guidance to set of what standard the principal designer regarding their qualifications, their experience and membership needs to be regarding those different scenarios of that project. These will be all in the slides for you to after the presentation to actually go through later. So we have that regarding technical knowledge of the construction industry, where it should be a chartered construction engineer, surveyor, architect, relevant degree. It all sets the minimum standards in accordance, as well as having the experience, the knowledge to undertake that role. So the designer's duties, just to start off in UK law under CDM, they must not commence any work in relation to projects unless they're satisfied the client or the developer is aware of their legal duties. And they must take into account this particular essential, which is the principles of prevention, and any pre-construction information, so to eliminate, so far as reasonably practicable, foreseeable risks to health or safety of any person during the construction phase, as we call buildability, for the workers and general public, during the maintainability, the maintenance and cleaning and use of that structure or building, to the use of that structure as a workplace. The actual designer also needs to take reasonable steps to reduce, and if not possible, control the risks through subsequent design processes. Provide information about those risks to the principal designer on the project, and ensure that appropriate information is included, what we call in UK a health and safety file. No doubt you may call it a maintenance manual for that building or asset through its life cycle. To clarify the principal designer's responsibilities, in addition to their role as a designer, they need to basically plan, manage, in a do aspect, just like any management system, monitor by checking that the designers are complying with their duties, providing the information we mentioned, the right information to the right people at the right time. The coordination by acting, and then back again to plan. Continual cycle of this plan, manage, monitor, coordinate, which, as you will know, as part of any management system, is plan, do, check, act. Same process, but by individuals accordingly. And there we have a demonstration of where integration as a integrated project team member is crucial. All it takes is one member not playing their part, whole thing stops or goes backwards or doesn't happen. And it's essential we actually work as a team, from the client, the principal designer, and all the design team, as well as the principal contractor, and ensuring everyone involved is proactive, doing their part, has the necessary skills, knowledge and experience. One of the things the Health and Safety Executive in UK did was change the terminology in line with what construction understanding of competence to the skills, knowledge, experience, but also training. And pre-construction information, which is gathering of existing information related to the building, structure, the ground, by surveys and so on, and design risk management. So the principal designer needs to provide pre-construction information from existing that's there from the client, and if it's not there, they need to conduct intrusive surveys and information about everything else related around the area for logistic purposes and transport, as well as the general public. and categorise the depth and the types and depth of the surveys, whether there's asbestos, contamination, geotechnical, topographical, utilities, structural, in accordance. Also, it's detrimental and it's been proven to actually highlight and try and address as early as possible temporary works, working with the principal contractor on this. Ensuring all designers, as we mentioned there, including the temporary works designer, complies also with their duties. And to cooperate and coordinate accordingly through the process, that is also a legal responsibility. Risk reviews undertaken at design meetings and workshops and recorded. It's important the workshops have the right people there representing the design, each designer, and actually contribute and agree clear actions, what needs to be done, using what we're coming on to very shortly, a register, tracker, schedule, log that actually states what significant risks are still remaining regarding buildability, maintainability, and use of that actual asset or building. So we come on to gateways, how to try and influence. There's many gateways in the UK have been developed since 2000, when I was seconded to the government under the Office of Commerce. And we have Transport for London, as you can see in the middle there, their own gateway process. And in conjunction with that, we can see their Network Rail and various documentation that should be provided during those gateways before practical completion. And we're talking practical completion is the end of stage 5, and the operation and maintenance starts at stage 6, and they're on from 7. And then finally, we see the new REBA process, the stages at the bottom, which have changed just recently, literally a month ago. They still run from 0 to 7, but there's a change to the terminology regarding number 3, the single option development, sabbatical development, and that include regarding construction, or at stage 5 includes manufacturing. So it means about designing off-site and manufacturing components to bring in modular form. So temporary works is crucial, as you've heard earlier, and there's various guidance that we have with British standards, and you no doubt have aware of is the Temporary Works Forum, which have produced guidance documents such as those to help designers and clients regarding what needs to be done early on, not just associated with the principal contractor. Here is an example of what REBA have been developing through Paul Bussey, who works for AHMM, which I'm working with, on developing design risk management courses for all designers, from ICE as well as REBA. And they've set this gateway process as a guide. And as you can see from the very top, they're looking at identify, quantify, clarify, notify, modify, and deliver. Those processes, and then working down on the left-hand side from the top to the bottom is various functions. But this will become easier when you look at this, how it works. The middle line from the top to the right there would apply to every type of project. The rest would apply to either a complex project or a different, a refurbishment where only some parts would be applicable. But it's a great guidance to help architects to actually identify what they need to do at various stages and not miss them. So it's great guidance that's already been done by designers for designers to ensure health and safety as well as fire safety is incorporated early. This is just an example of a design control, change control process where clearly when there's a design change, how it needs to be gone through a process to be signed off. And again, back to this information to the right people at the right time is crucial. That's not clearly, we've done a design change and the contractor's only aware by it, by a drawing, and didn't pick it up till later. There's a terminology called pre-construction phase, and this is written in the Health and Safety Executive's L153 guidance supporting the CDM 15 regulations. Means of any period of time during which a design or preparatory work is carried out for a project that may continue during the construction phase. In other words, there's an overlap. It's not just the construction phase. In other words, there's always design changes happening. There's always a scope creep where surveys may have to be undertaken in addition to what was before. So it's continuing information needs still to be gathered. So there's a clear overlap between pre-construction as well as construction phase regarding the principal designer and designer's responsibilities of providing information during any design changes. And the term significant risks. To try and reduce bureaucracy and extra paperwork that sometimes that health and safety is perceived by some, we've clarified that only significant risks need to be recorded that obviously are not obvious to a competent principal contractor and their contractors. So we need to flag up only significant risks, not trivial and obvious. And that what significant risks mean, as you can see there from the guidance, it's not necessarily those that involve the greatest risks, but those in brackets including health and safety risk, end of brackets, are that they are not likely to be obvious and are unusual or likely to be difficult to manage effectively. So they need to be flagged up early and help the contractor realise, hang on, we need to look at this and work together on a solution. And this is just an example of the documentation regarding a schedule of surveys, which we have various guidance for. We mentioned earlier asbestos, utilities, overhead power from not just underground utilities, but overhead power lines to general surveys accordingly. And what we do is have a tracker of identifying what surveys have been done and still to be done, or whether they actually are sufficient by using red, amber, green. On the next slide, we see typically a pre-construction information document, gathering information of the site, what hazards, what risks are associated, and you can see a template there of a risk register, schedule, tracker, log, whatever you want to call it, drawings highlighting using symbols, which we'll come on to later, and obviously where the utilities are based upon the surveys that they've gathered at that particular time. So a design hazard. What is a design hazard? It's something with the potential to cause harm. That's what we want to be clear about, the differential between what is a hazard, what is a risk. And you can see from the Laurel Hardy sketch here, what is the hazard? Is it Laurel on the top of the ladder? Or is it Hardy down the bottom holding the ladder? Or is it the lady? Or is it the car? Is it the ladder? Well, the hazard is working at height or trying to work at height. And here we have another situation. What's the hazard here? The person, the soul, the person falling into the road, or the actual plyboard that's standing on, slipping and not hitting a pedestrian and taking their legs under them. So what is the design risk? Well, it's actually the likelihood. It's based upon the likelihood versus severity, or should I say the probability versus the consequence of that occurring. And you can do it all means. If you're doing a petrochem station, a nuclear power station, very complex project, you probably do various quantification of numbers, as you do regarding HAZOPs and hazards and fault tree analysis. But do you really need to be doing that for a small refurbishment or a clear project that's quite not so complex, and keep it simple by using red, amber, green, high, medium, low, which we'll come on to. So there's various acronyms and terms in CDM, as we've already come across during this slide. It's reasonably practicable. is about balancing the level of risk against measures needed to control the real risk in terms of money, time or trouble. However, you do not need to take action if it would be grossly disproportionate to the level of risk. This is a guidance that's again in the L153, trying to get clarity, trying to mitigate the confusion that we initially had with CDM. There, you've seen before, is about significant risks that we covered earlier. And we mentioned the term general principle prevention, which is a legal duty for all employers under the management regs, but also a duty for the designers, principal designers, and our friends, the principal contractor and contractors alike. And what it does, it sets out the approach and principle for all duty owners to control those risks to health and safety within the project. So to summarise, without going for the 9 points which it covers, it's to avoid or eliminate risks where possible. Evaluate those risks that cannot be avoided. So it's more or less look at, going back to the A, avoid, eliminate, is the elimination. Just like, and then the next one is about reducing. So we're starting to look into the ERIC, using ERIC as an acronym. It's nothing to do with Eric Clapton, if you like his guitar sound. It's an acronym we use. ERIC means, as an acronym, eliminate, reduce, inform, control, which we'll come on to later. So finally, in conjunction with that, is provide proportionate measures to reduce, control remaining risks at source, including, we have to, as we all know, a prevention policy, and the use going forward, as we are doing, is digital technology in various ways, which we'll touch on. Here is a diagram about, from left to right, at the bottom you can see the gateways, the phase, what we call the design stages of a project. As you can see, the cost of any will become higher if the changes are done later, as we can see here. If you decide to identify, hopefully there needs to be a design risk eliminated or reduced early on in the design stage, you're going to save a hell of a lot of money in the medium to long term. But if you leave it later, yes, it's good at that stage, but then later here, then hang on, we should have looked at this earlier. We should have done something about this earlier, because now we've pressed on. But then we come during the construction phase, particularly for design and build, where the principal contractor picked up something the initial designers didn't, it's not so good because of the cost implications later. So it's important to get this from inception, as you can see at the bottom, regarding the gathering of information, particularly using building information modelling, as you were aware, regarding digital, this golden thread and this single source of truth to the end user, having all information in one central source using a common data environment, of all capturing all those hazards and risks, and all the way through for the actual maintenance manual, our health and safety file, as we call it in UK. Here, going back to the principle about a LARP, as low as reasonably practicable, and establishing that. This is a model that was, you can see there, eliminate, substitute, engineering controls, admin control. This came from America, from the American Engineering Council. And you can see the level of risk, the time, duration from the project from inception to completion, from left to right at the bottom, and the reduction of risk. Now, to keep it simple rather than that, is using the ERIC, as we mentioned earlier. It's using that process of eliminate, reduce, inform, and control, looking at these aspects all the way through. So do eliminate as much as possible. If we can't eliminate it, can we reduce? If not, we need to inform. If not, we need to control. If not, it's a case of inform and work together on. So back again to single source of truth, from inception to the end user of that information. Regarding quantification, we touched on earlier about various methods of quantification. There's 10 by 10, let alone 3 by 3, you can see on there, and 6 by 6. But it's down to the actual business, the team, to decide how they want to quantify regarding likelihood against severity, or should I say probability against consequence, whichever. And what we also have is the RAG system, red, amber, green. And what is green, as in the low, this is what we need to be designing in. And then the amber, what we should be, hang on, is it's not ideal, but it's a halfway place. But the red, we shouldn't be designing in. These are the no-nos. We should be doing this, we shouldn't be doing that. There's a clear list. And what we have there, as you can see, is related to every different sector, from highways, building, rail, tunneling, to power generation, such as energy. We showed earlier the Syria guidance. This is just an example of one of the pages within the Syria guidance related to construction. And as you can see on there, we have from left to right, which should say hazard first, working at height. The risk from working at height is falls, obviously. And that is the biggest killer in UK regarding construction physically, is working at height and falls. So there's various what we call prevention measures required to aid the designer to look at, to eliminate that early on as possible. Here is just an example of what some Caledonian University have been trialling with various architects and engineers, both with experience or not experience, to identify pictures paint 1,000 words, by not just having text, but actually having pictures related to what type of works happen and what they need to look at. So they're trialing this, have been trialing it for the last 6 months, and gathering information how they are now helping designers to flag up things that they wouldn't know about until the actual construction works took place till later. Here is an example of a hazard elimination schedule, which has been basically developed by Highway England, which is, as you can see, it's very complex. I'm not a fan of this one, but this is what's been implemented to order to track, schedule, whatever, what hazards, what risks are taking place and need to be recorded and flagged up to the contractor, working with not just the design team, as it should be, but also with the contractor all the way through the project. And it's just an example what they're using. Here's a far simpler method, as you can see, regarding recording initial risk, and then what mitigation treatment is done to reduce it to residual risk, and then using symbols and trying to realize, hang on, can we incorporate that in the BIM, in the building information model, like so. And here's some examples where sketches are done by architects of flagging up using symbols. So this sort of practice is starting to happen more and more, of it again flagging up the not so obvious early on in the process, and looking at various methodology before construction work happens. As you can see from this example here, what helps with this diagram, and just the symbols alone, is pictures of the existing building, identifying hazards, identifying risks that need to either be eliminated or reduced. And here's some, again, more examples of how they're looking at it as a recording, but sharing information as they go along. Here's another one, particularly to do with occupational health, which is a big issue, as you're all aware, more than just the physical aspects related to safety. And there they're flagging up various things regarding silica, musculoskeletal disorders, hand-arm vibration, of what needs to be addressed early on, rather than leave it to the contractor later down the line. Here's some examples of where mitigation treatment solutions being applied. You can see by having guardrails fixed, installed during the actual construction works, using of mutes. So it's preventing work regarding addressing the issues regarding working at height. Then we have this regarding glazing installation, while they're doing rather than physical application or working from outside, they're actually working from inside. And here regarding the roof, where the actual skylights, roof lights are actually covered, preventing people who are doing the maintenance, let alone prior to handover of the project during the construction, from accidentally sitting on them or walking over them. To the right-hand side, actually fix guardrails as part of the steelwork, not have to be built on later, actually part and then cut off accordingly. And here regarding utilities, in the utilities field of actual preventing confined spaces, as well as manual handling issues accordingly. And here we have obviously hoardings that's actually part of the actual process, built in from early days during the design to here, that you have the actual plant area covered all off. From view, yes, but there's prevention of falls accordingly, operating under the permit to work. But also here, if they go outside the work, they have to clip on using a harness, a restraint harness accordingly. And here again, using the mutes regarding installation, so there's no walking of steel. We're doing the actual installation. And down here, we see how steel is being erected and has specific lifting eyes built in to the actual, so the center of gravity. There's none of these problems of slipping chains and steel falling during the actual installation works. Coming on to the actual building health and safety manual, maintenance manual, whichever we call it. These are a typical example of what everyone was perceived it to be, all paperwork, files, folders that just gather dust. But actually, why can't we be using digital? Why aren't we using digital? And this is just an example of what National Grid has been doing, is gathering information and collecting it accordingly. And capturing information is absolutely crucial using digital, as explained, tried to be explained on this here. So, digital design for safety, the future, as you can see, that's an old diagram recomposed with the technology of today, possibly. But it's more about integration using digital to our advantage of walking through an old process in 3 or 4D before actual construction works take place, or during prior to the next stage of the project. And here is many things that are being trialed and developed and continuing to develop to help people flag up things earlier with the contractors of setting up solutions going forward. So there's various great case studies starting to come out of where design for safety using digital has really enhanced things going forward. And in conjunction with that, we have the PAS 11926, which was produced 2 years ago in 2018. But also we now have the ISO 19650. As you're aware, CIC starting to develop to support this. But part of the Health and Safety Executives BIM 4 working group, we've developed a employer's information requirements, now known under the ISO as the Exchange Information Requirements. And what that is about is setting what health and safety risk information do we need to be built into the building information model from the early days, and specifying what that needs to be. What type of symbols, what type of registers, how do we gather it? Keep it simple, proportionate, not overcomplicated, and clear and simple, and where it's tracked through the project. And that is essential to be done early doors rather than wait till the principal contractor comes on board, where they see massive advantages using building information modeling regarding clash detection. However, miss out, and the client misses out on this, on the maintenance and operation and use, where we need to be flagging that up as well as part of the maintenance manual, health and safety file, which the building information should contain, which is what we're now starting to do more and more now, is educate clients the benefit of this for their asset, their building going forward for the life cycle. This is just a diagram of what's in the PAS 11926 series of regarding, yes, they call it likelihood against consequence rather than probability against severity, whatever. But it's just illustrating what designers and contractors alike who have design responsibility should be looking into during the design and with the client, and who should be doing what, when and how through the process. And this needs to be built into the contract through the employer's information requirements and exchange information requirements accordingly. This one is from National Grid. It is an example of where they, working with their supply chain, have been doing digital rehearsals versus in reality. And what we mean by that is, you can see on the left-hand side, is this is all in 3-4D. And they've taken it, this is the site before anything else is in the ground. This is a greenfield site, and they've imaged of how the site would look with a library of plant and vehicles and all types of equipment exactly to size, and reimposed how it looks on the ground prior to actually how they actually did it for real. And they went for various digital rehearsals doing this in order they got to this solution here, in order they had no accidents, no incidents. And they would have, and the same with this diagram here, where they then brought in the crane. How would the crane position? What type of crane? And trialing this, they realized there was a better option by using this method. So it certainly brought to light, this digital rehearsal has brought on massive benefits, but also used as part of the method statement to visualize what needs to be done by whom regarding their sequence of work. So it helped enable, as an aid memoir, to not just for the inductions to the site, but also the method statement briefings for the contractors. So just to summarize, there's a lot to cover regarding design safety, and it's foresight is not just hindsight using models and risk registers, or what do you say, schedules, trackers, logs. Procurement, setting the one platform and a common data environment is crucial for an employer's information requirements or exchange information requirements early on in the project. Combining design for manufacturing and assembly and building information modeling has its massive benefits. Embracing digital tools to identify significant risks and make a difference earlier than we should be doing. Workshops using 3 or 4D to identify any risks and provide solutions. Capturing the right information using digital for building or structural asset maintenance manual, the health and safety file. Back to this, as we said at the start of the presentation, ensuring the right information is provided to the right people at the right time during all the life cycle of the project, and not just during the construction phase. So thank you very much for your attention. I understand there's a number of questions that you've been sending over, which we will be going through accordingly. So thank you very much for your attention. I hope it's been beneficial, but I look forward to your questions, which I'll try and answer as best I can.
Yeah, no worries. I've got a lot of questions for you, Steve. So thank you, Steve, for your very comprehensive presentation. It seems it requires quite a lot of collaboration to make the design for safety process. So we have quite a lot of questions, so we have picked up some of them and see we can go through all of them, but it depends on the time. Okay. So Steve, can you hear me?
Yes, I can hear you, Tony. Thank you.
Yep. So maybe we start from this one. Okay. So someone asking for building project in the UK, would the project depend upon the architect as the designer or the engineer as the designer?
Okay. And what we're asking what responsibilities they have?
Yes, exactly.
Okay.
They don't know what is their responsibility.
So for building projects in UK, would the project client appoint the architect design? Yes.
Yep.
What would happen in the UK currently is that for a building project, normally the architect's appointed as the lead designer. So subsequently, they become the principal designer.
Yep.
But in some cases, we found that lots of lead design practices, architects still don't have the competence in-house, so that we outsource it contractually to a consultant to help them, to assist them comply with their duties.
Yeah.
This intentionally has exposed that the client needs to have somebody check in that they're actually fulfilling their role.
Yeah.
When we come on to infrastructure projects, it's generally the engineer becomes a lead designer of a huge infrastructure project, such as Tideway, the Highway England project, the HS2, for example.
Yeah.
So they become the principal designer accordingly. But when we come on to design and build, by default, because the design and build contractor becomes the designer in control, at stage 5 of REBA, the principal contractor becomes also not just the lead designer, but the principal designer. So there's a handover there. And in some cases, the principal contractor novates the existing architect, who was the lead designer at the start, to be part of their team contractually. But the responsibility is with the principal contractor to fill the role of principal designer, even though they may not have the in-house capability at the start as they should have. So it's quite interesting how we're trying to educate builders to look at maintainability and usability when they're obviously their competence is all about buildability, or it should be. And so there's still a transition going on of education of ensuring we've got to look at the whole thing collectively related to buildability, maintainability, and usability. And we can only do that as a team.
Yeah.
And so there is still some flex in there and development. And I've been holding workshops with the health and safety executive. Various parties have seen what's working, what isn't working, and what solutions we need to be doing as we go. And it's about education. Education is crucial, about not a case of who's doing what, when, but understanding the basics of what is a hazard, what is a risk, and what do we need to be prioritising, and keep it sensible and proportionate to the project, as in complexity of the project, accordingly.
Okay, so I understand why they're asking this question, because I think they're thinking about the competency, as you mentioned. So let's come to the other question. I think this question, some people is related to the first one, and I pick it up from the question now. They're asking, is there any regulation to control or examine the designer, the principal designer in UK?
So what's that question again?
This one has come up suddenly, not on the list I sent you just before. Is there any regulation to control or examine the principal designer in the UK?
Yes, the CDM regulations.
Yes, the CDM actually got some area to control the competency of the lead designer. Yes, the construction design management regulations stipulate every duty holder has to have the necessary skills, knowledge, experience to fulfil their duties, and need to demonstrate that. And there's various ways of sort of being questioned
as an organisation? Do they have the capability? Do they have the skills? Do they have the experience of fulfilling those duties?
Yeah.
And one of those things is obviously they need to be a designer, to be a principal designer. But secondly, do they have the in-house health and safety procedures addressing health and not just safety alone? And how they collate that, how they track that information accordingly, and how they're making a difference, how they're collating the pre-construction information from surveys, how they actually are working with the principal contractor to help them develop what we call the construction phase plan before work start, but also how they're gathering information for this maintenance manual called the health and safety file. And that's a big question, how they collate that information for the benefit and operation and use for the client or the end user. So these are the questions we continue to ask before they are appointed. And there's a lot of design build contractors I'm finding that don't have the expertise that they should at this moment in time. So still lots of education and upskilling required at the moment, even on major projects.
Right. So thank you for that. So I got the other one coming up. What was the biggest challenge for launching the CDM in UK?
There was a number of challenges. One was conception of this and saying, what's this new principal designer role, as we just mentioned, which replaced the old CDM coordinator. And there was a lot of pushback from consultants that had a career at doing the CDM coordinator that wasn't a designer. And they saw a massive threat of this well, they're not a designer. They didn't have any design experience, or if they did, they didn't have the qualifications. They weren't a member of ICE or REBA or RICUS or CIOB. So some of them either changed and had to upskill themselves and are still doing that. Others just became advisors and disappeared. And the big challenge was architects taking on the role. Some, about 20%, have embraced it. The larger architects have embraced it and have the in-house capability by having a team or individual that's helping them educate what they need to be doing accordingly. But also the principal contractors we mentioned had taken on that role. They saw opportunity there that they could be in control of design without a consultant checking on them. And that's been a bit of a comeback for them. So there's been this sort of step change of understanding to say what's working and what isn't. And it's all about that, can I say, back to the word collaboration, communication, consultation, cooperation, competence, as well as commitment from all levels to make that happen. And it needs somebody advising the client from the front end to say, look, have we looked at this? Have we looked at that? And not miss these things. So these are things that they're now starting to develop out. They start to see as benefits that it should be an integrated project team approach, as it should have been from the start, not bolt-on and separate individuals doing different things.
Yes. Should
be integrated.
Okay, so I think it's the big challenge is to get all the people come together to work out.
Absolutely, it's essential.
Okay, so we still got 5 minutes, so maybe we get the last question. And the last question is: some people said the CDM create a lot of paperwork, and there are doubt about the effectiveness. So, what is the general feedback from the industry?
Initially, when it came, the first CDM came in 1994, and it came into law in 1995. There was a lot of consultants developing bureaucracy. What we used to call the pre-construction information was pre-tender health and safety plan, and that plan, as it was called, developed initially as part of the tender exercise before the contractor was appointed. Was going in 200 pages of justification of the appointment of that, what was then the planning supervisor. Now we have this principal designer, where the whole focus is, from the HTC's point of view, is it's got to be sensible and proportionate, the information, in words, relevant to the complexity of the project. So what we're looking for is information that's relevant and it's proportionate and it's sensible, if that's a word we can use. In a word, not baroque, like you said, there's lots of paperwork, you can't see the wood for the trees. That's not effective. That doesn't help. What we need to know is what hazards, what risks, what are the fundamental things, which are significant risks, that we need to know to plan for and understand how to manage it and control it. So he said back to this education again of ensuring the right information, yes, is simple and proportionate to what significant risks are remaining. Not everything in the kitchen sink, trivial risks and all sorts, just to make it, well, more information the better. No, we've got to break it down so people can understand it and prioritise things. So that has been one of the challenges, is to again back to this education. What's sensible, what's proportionate and relevant to the project we need to provide to the design team, but also the contractors tendering for the work, but also information flow as when the project starts and is continuing to practical completion.
Okay, so the training is the crucial part of the design for safety, to make sure everything is doing for value, not just only a paperwork.
Yes, and that's why we've seen digital far more way of, cutting down that bureaucracy by one single source of truth, as we mentioned on the presentation, a SharePoint, a portal such as a common data environment where all the information is being dropped down in there and shared and updated in one place rather than attached on various different emails floating about.
Yeah, thank you. So we come to the end of the webinar. So thank you for your time, Steve. And I think we still got a lot of things I want to go through, but unfortunately we got 1 hour's time for that. So maybe we have other chance to doing that again. And,
no. There's lots of other things I can share with you on the digital side, particularly of what's been progressed, as well as the education side, what tools to help designers and contractors alike to understand how to identify things easier.
Okay, so thank you for your time, and I will see you later. And thank you everyone for watching. So just staying tuned with CIC for the coming webinar series for design for safety and other topic. So thank you very much everyone for joining us today. So see you next time.
Well, thank you everyone.
See you, Steve. Bye-bye.
Thank you.